Here's example 6 of using double angle formulas, and it's another establish the identity problem. So the identity we want to establish is secant of 2 theta equals secant squared of theta divided by 2 minus the secant squared of theta. Okay? So the same thing that we always do with every single establish the identity type of problem is just pick one side, work only on that side, just manipulate that one side, leave the other side completely alone, and try to make that one side look like the other side. Okay? So, and then after that, the thing that you almost always do is start on the more complicated side. So we're talking about double angle formulas, so here's our double angle, secant of 2 theta, and then here's the other side here. This other side I think is a little more complicated because we have division, we have things being squared, there's some subtraction here, and over here all we have is one trig function of a double angle. So that's not really that complicated. And also, if you try to start on this side here, first of all, we don't have any double angle formulas for secant, but remember secant is the reciprocal of cosine, and we have 3 formulas for cosine. So we could try one of these as a reciprocal here, but we eventually might get stuck. It might not really be obvious what to try next. We could actually do it that way and it will work out, it wouldn't be that bad. But there's one particular step where it's not exactly obvious what to do, but if we start over here, then it's not quite as bad. So we'll start over here because it is a more complicated side also, so we'll try that. So let's go ahead and get started with that then. Okay, so secant squared of theta, all divided by 2 minus secant squared of theta. Okay? So now one thing to try, one of the methods or techniques to try that might not work in every case is to convert to sines and cosines. Now it might not be obvious to try that because our goal eventually is to get secant of 2 theta. Well, remember, we don't have any double angle formulas for secant. Oh, and by the way, if you want a copy of this formula sheet, check the video description, there's a link there. You can click that link to get a copy of this. We don't have any double angle formulas for secant, but we do have some for cosine. Okay, so we're probably going to have to go through cosine at some point to get to this. So let's introduce cosine into this mess here. So remember, secant is the reciprocal of cosine, so secant squared is the reciprocal of cosine squared. So secant squared of theta is the same thing as 1 over cosine squared of theta. And then this is 2 minus 1 over cosine squared of theta. Okay. Now let's try and get common denominators and simplify a little bit. So on the top we just have 1 over cosine squared of theta, not much else happening up there. But on the bottom here we have a 2, let's make that a little neater maybe, 2 minus 1 over cosine squared of theta. Okay, so what we're going to do is take this 2 and multiply the 2 by cosine squared over cosine squared of theta, so that we have a common denominator now. Okay, so when we do that, what's going to happen is that top stays the same, 1 over cosine squared of theta, and then on the bottom we have 2 cosine squared of theta over cosine squared of theta minus 1 over cosine squared of theta. Okay, so now let's squish that all together in the with the common denominator. So the top still stays the same, nothing happening yet. Then on the bottom we have 2 cosine squared of theta minus 1, all divided by cosine squared of theta. Okay? So this fraction on top divided by this fraction on the bottom. So what that's going to give us is the fraction on top multiplied by the reciprocal of the fraction on bottom. So this equals 1 over cosine squared of theta times the reciprocal of the bottom, which is going to be cosine squared of theta over 2 cosine squared of theta minus 1. Okay, so then cosine squared cancels with cosine squared, that's great. Then what we're left with is just 1 divided by 2 cosine squared of theta minus 1. Okay, and then here, hopefully this looks a little familiar, but if we go back to our formula sheets, then what we see is cosine of 2 theta equals 2 cosine squared of theta minus 1. So that's one of our double angle formulas for cosine. So 2 cosine squared of theta minus 1, that is cosine of 2 theta. So this is 1 over cosine of 2 theta. Remember, cosine and secant, they are reciprocals. So here, remember we said earlier we're going to have to go through the double angle for cosine, and that's exactly what's happening right now. So secant is the reciprocal of cosine, so 1 over cosine of 2 theta is secant of 2 theta. And that's exactly what we wanted. So that's it. Okay, So that's example 6 of double angle formulas, and it was another establish the identity type problem. So just to recap what happened at a high level. So we started with the more complicated side, and remember, you only work on just one side. Pick one side, just work on that side, leave the other side completely alone. Don't do anything to it at all. So we picked the more complicated side. First we said, okay, let's convert to sines and cosines, because, well, it's really just going to be cosines because it's a secant. So let's convert to cosines because we eventually want secant of 2 theta. We don't know any formulas for secant of 2 theta, but we do know formulas for cosine of 2 theta, and that's the reciprocal of the secant. Okay, they're reciprocals of each other. So we're probably going to have to go through cosine of 2 theta to get to here. So let's introduce the cosines right here, since there's not a whole lot else to try right at the beginning. So we did that, then we got a common denominator, simplified a little bit. After simplifying, we ended up with this right here. And we said, okay, this is the cosine of 2 theta. That's one of our double angle formulas. And then that gave us exactly what we wanted right away. So 1 over cosine of 2 theta, that's secant of 2 theta, because secant and cosine, they're reciprocals. So that's that. That's example 6 of double angle formulas.